So today I am focusing on uh, the basically the two calculation which I'm going to discuss. One is called t-test. In the t-test, I'm focusing on one sample t-test, dependent sample t-test, that's nothing but per sample t-test, and one more independent sample t-test. There I'm going to highlight when we can use it, where we can use it. And parallel, I'm focusing on today one-way ANOVA. And parallel, I'm going to highlight the repeated measures ANOVA. So this is a four calculation. I think to conclude, cover this four. It's based on the timing. Suppose if we not be continued today, I will continue tomorrow. Don't worry. So my focusing on today t-test as the one way ANOVA and repeated measures ANOVA. These are the area I'm going to focus in. Before deeply about these things, you must be familiar with some of the things, particularly when we can use this kind of statistical procedure. Okay. So first you must know the quantitative data. Yesterday we were discussing about nominal, ordinal, interval ratio because these four things based on it, we need to decide what kind of statistics we need to be go further. So under this, I'm just going to give you an overview about that. And good. So just I'm going to start with the parametric and non-parametric statistics. Because if you're familiar with parametric and non-parametric, even we can know that what is the equivalence of the t-test, what is the equivalence of the t-test in the case of parametric and non-parametric. And suppose I'm like to do a post sample t-test. If in normality not satisfied, you must know what is the equivalence of the non-parametric while doing the similar kind of post sample t-test in the case of non-parametric. These are the basic idea you must know this. That's the reason I just started with parametric with non-parametric analysis and just give the insight what is called parametric and non-parametric. So listen, there's a four conditions it decide or the criteria it's going to decide what kind of statistic we need to do this. So please kindly take a screenshot. These four conditions, you don't forget. These four conditions are the criteria. It decides whether you need to go with the parametric or non-parametric. So I'm just going to give you insights. The first one, assumptions. So what is called assumption in the sense? The assumption in the case, it is called normality, right? You know that the distributions, that there is a two kinds of distribution. Basically, it's called normality. Other one is called non-normality, right? Non-normality we may call as a free distribution. Listen, there is a two kinds of distribution. There will be normal distribution. Other one is called free distributions. So therefore, you have to decide if your distribution satisfying the normality, listen, if the distribution satisfying the normality, go with the parametric analysis. If your assumption or distribution satisfying the non-normality is nothing but free distribution, like you know that is called skewness or scutters is satisfying, and parallelly it comes in free distributions, like a free distributions, then we need to go with this non-parametric. So this is the first condition, it deciding whether we need to go with the parametric and non-parametric. Hope you are getting this. The first criteria you must look onto this, whether your data set, the distribution, it's satisfying the normality or not. If it's satisfying the normality, go with the parametric. If it's not satisfying, go with the non-normality. That's called non-parametric. The second one is a data type. Listen, this is a very important. Even sometimes, even the normality not satisfied, kindly check deeply on data type. So as you know that, as yesterday itself, we discussed that the entire scales of measurement we can divide into two classification. One is called categorical, other one is called continuous. We discussed these things, right? Categorical, we have two things. One is called nominal, other one is called ordinal. In the case of categorical, we have nominal, ordinal. In the case of continuous, we have two, interval or ratio. So these things is going to decide what kind of strategy you want to do this. Listen, I'm talking about data type in the case of dependent variable. I'm talking about the dependent variable in this context, not an independent variable. If you're dependent variable, it is satisfying the categorical nature, like it is nominal, ordinal format, then you can go with this non-parametric. Please kindly know this, non-parametric. If the categorical nature, go with the non-parametric. If it is continuous nature, like interval or ratio, we need to go with this parametric. So hope you get the second condition. The second condition to decide a parametric, non-parametric is a data type. So we have two kinds of data type basically. And talking about the general aspects, one is called categorical, other one is called continuous. In the case of categorical, we have these two, like nominal, ordinal. If a nominal, ordinal variable, go with the non-parametric. If it is interval ratio, it may be continuous, then you can go with this parametric. Yeah, the third condition is a sample size. The third condition is a sample size. So you know that basically the sample size is a large sample or a small sample, right? Sample or a small sample. If it is large sample, the sample size more larger. I'm talking about large sample. Then you can go with this parametric. And if the sample size is very small in nature, go with the non-parametric. Parallelly, the sample is, when the sample is large, either sample is to be known, if the known population, then we can go with the parametric. If the sample, it is not a known, right? It is an unknown population or unknown sample population, then we can go with non-parametric. And parallelly, the people are looking onto this. When you go with the probability sampling, automatically there is a possibility the large sample, then you go with the parametric. Similarly, if you go with the non-probability sampling, there may be a chance the sample will be less. It will be take less sample, then you can go the non-parametric. The fourth condition, very important. Listen, the fourth condition. Suppose if you are doing the calculation based on the mean, actually, in the case of Messrs condition is very important role. We know the mean, median, mode. If you are doing the calculation with respect to the mean, for example, when you go the t-test, f-test, no, it directly, we are going to compare the mean differences only. Mean difference of the two groups or more than two groups. So when you use the mean as a main medium to do the analysis, then it is called parametric. If you like to compare with mean basis, then go the parametric. Instead of that, if you like to compare with respect to the median, instead of mean, if you're taking as a median, normally the median is nothing but ranking like a position. When you take as a median to do further analysis, then it is called non-parametric. Non-parametric. Hope you are getting this. I just give the insight. So there is a 4 conditions decide a parametric, non-parametric. The first condition, distribution. Second condition, data type. Third condition, sample size. The fourth condition is measure standard tendencies under this mean means parametric. Median, if you are using, it's called non-parametric. You can see this. They may call as an fragment rank test or rank correlation. That these are the things part of the what is the non-parametric because it's a rank-based calculation. Whenever you do the calculation based on the median or rank basis, automatically come under the non-parametric. When you do the calculation based on the mean basis, then it is called as a parametric. So any doubts about this, please kindly, if you want, I can go to the next slide.
Yeah, sir, one
also.
doubt.
Yeah, please.
Sir, regarding
please.
this sample size, you
Mm.
said about this unknown sample non-parametric.
Yeah.
When it is unknown, it is larger, na? How can it be a non-parametric?
No,
because
no, I mean, unknown means we cannot be limited. I'm talking about that context. Okay. Unknown is not be finite. I like you can use the word finite, infinite. That's the things I'm talking about this. So sometimes the sample may be known. I mean, we can be able to know where is the sample, where is the population there. Okay. For example, I'm taking as a this one, transgender. Okay. The transgender basically is in you can take as judgmental sampling as well as you can take a snowball sampling. You cannot be what is the find where it's possible then. Okay. And one more thing, the sample size, we are decide that the sample size is less than 30 is below, I mean, small sample, above 30 is a large sample, but don't be confined with this. But instead of that, we have a lot of calculation because the sample size, the large sample, small sample depends on the your populations only. So I'm just giving the insight. If you want to go with this, the sample size calculator, just go to my same website, digicog.info. The large sample, small sample depends on the population only. Okay. So when you go to this digicog.info and just copy and share this link. So 1 minute, and just share the link in the chat box.
No, you shared it yesterday, sir.
Oh, the same link, but under this another link, I'm sharing it. Okay. So the less than small sample, that why that less than 30, above 30 is called large small? Because previously we used statistics based on the manual or based on the paper base, but now we are using the statistical tools and all, like different softwares. So therefore, better to find out this kind of sample size with the use of some kind of tools. So for this, you can go to the statistical resources. Under this, there is a called digital tool for statistics. There's another web page. Just sharing this link. That's sharing this particular link. When you go to this link, you can find out there is a sample size calculator. You can see the sample size calculator. We have a lot of sample size calculators. When you click this, you can go with the survey maker check mark at the survey system. When you click this, it leads the web page, the particular site. Here you can type the population. Listen, the population size you must be aware of it. That's called, I'm talking about the finite populations.
Fine.
If you know the finite population, if you're able to locate it, then you can type the number. That also you need to find from secondary data, right? It not be randomly type the population size. Population size you can find from the secondary data. You can locate from this, or you can find from this. Suppose I'm doing the research with respect to the B.Ed students of Karnataka. So for example, there is a 1 lakh students of Karnataka of B.Ed. So I'm fixing the confidence level, and margin error I want to keep it only 4%. So my sample size is 597. I have to fix to do this analysis. But this is only for survey method. I'm talking for the experiment method. This not be perfect, and because this is not be a things. And you can see this, the desired confidence level and Z score, everything they given here, and population size. If you want to reduce this, for example, I want to reduce the error. That how to reduce the error means, if you want to reduce the error, you can increase the sample size. For example, I want to reduce the error into 3%. My sample size is 1054 for the 1 lakh population. So this way we can find this sample size through this kind of tools. We have a lot of tools freely available. And one more thing which I telling us, a finite, infinite, that aspect I'm telling. So known, unknown, you can think about that aspects, right? Hope you are getting this.
Sir, suppose
What is the
my
case?
population is students of 7th class of Delhi. So it's really difficult to give an exact number of population. So what should we write in such cases?
You can find out because the 7th students of Delhi, you can easily find out from the different databases. You can approach the government sectors, or you apply the get in the district what is that DEO of our Delhi. You may get into this. So we need to find this. We cannot be what is that? This is called final. Basically, we can able to find this, right? These are the
Okay.
data are already available. Okay, so we cannot
Okay,
go
thank
with
you,
this.
sir.
Okay, so don't think that the 7th is not possible to get, because this is a known population. People's, if you approach the different CEOs, you may get into this. Yeah, DOs, CEOs, you may get into this. Or you can find out a lot of databases are available. In the government databases, every year, the number of enrollment of the every section they giving this government database. Kindly find from this. Right. So this is 4. The second condition, data type. I'm just sharing this. You can see this. Yeah. This is slide, one more slide. It may be helping you. The same thing I'm discussing about the parametric, non-parametric. As I already mentioned this, in the case of parametric, we have normality. If it's satisfied, go with the parametric. If it no strict action like a free distributions, then go with this non-parametric. And data type, if you have the interval or ratio, it's like a continuous data, go with the parametric. And if the data, it is in categorical, like a nominal, ordinal, particularly I'm talking about this one. So there is a question from Anil. If in the case when my data belongs to loss sample size, free distributions, sample from known population, what would be the parameter? Listen, if it satisfies normal, better go with the non-parametric. Like if it's free distribution, go with the non-parametric. So these are things we need to be decided. And as already yesterday itself by discussing about normality, we can find it from the 3 way. One is called number basis. The second one, visual representation. Third one, statistical procedure. This we discussed yesterday. The number representation, we are talking about skewness, kurtosis scores. Skewness divided by standard error of skewness. If a score comes plus or minus 1.96, or if it comes, some of the textbooks talking about plus or minus 3 also. Visual representation, we can go the histogram or the QQ plot or box plot. If it's satisfying the appropriate manner, then go with this. The third one, you can go the Safraville or that another calculation. You know that yesterday we discussing about this KH test and all. So this way we can ensure it's normal or not. If it not be normal, if the 3 conditions not satisfied, then only can think about the non-parametric. Hope you're getting this, Anil Chitra. And the other one, sample size. The largest sample size, you can go with the parametric. The small sample size, it goes with the non-parametric. And center tendency, as already mentioned, the mean, if you're focusing, you can go with this parametric. If you're focused on the median, to do the further analysis, go with the non-parametric. So this is a basic understanding about the parametric, non-parametric. These are the 4 conditions only decide parametric and non-parametric. Yeah. So, but basically the power of statistics, it depends on the parametric only, because Non-parametric, not that much power. So the power in the sense I'm talking about the generalization. So generalization is possible with in the case of parametric statistics, because in the case of non-parametric, the sample size may be less. Even if you're adopting also, the generalization is not that much of appropriate. That is the reason the people are, for if you like to go with more generalization of your research work, go with the parametric. Yes, these are things I'm just skipping. And one more thing, you must know that scales and statistics directly related to this. Based on the scales of measurement only, we decide a statistics. Even I discussed these things previously. Now, please, if possible, kindly take a screenshot of this diagram also, this flow chart also, because everything is to be directly connected. Now we can see this, as already mentioned this, these two things. What about the ratio and continuous? What it called? Ordinal, nominal interval is called? What is it called?
Categorical.
Categorical.
Yes.
This is called continuous. Yes, this is called
Continuous
continuous.
display.
This you know. Yeah. So this is the two things you must be aware of it. Now, you know that the weakest scales of measurement, it is nominal, and next is ordinal. This is the first level, second level, third level, fourth level. So it's like weakest to strongest according to the scale, according to the strength. And another things, you know that normally the categorical data we may call as a qualitative data, right? Qualitative is a categorical, it's called non-metric. And in the case of interval ratios of continuous, automatically come under the quantitative data. It may be called as metric or continuous data. So the example, and just height and weight for the ratio, temperature, IQ for the interval. But when you're using this kind of ratio and interval base, we can go with the parameter. That is called data type I'm talking. The data type of second conditions of normality. So second condition of parametric, non-parametric, I'm just talking about data type. If your data type is continuous nature, go with the parametric. If data type is in categorical nature, go with the non-parametric. So these are things only I just discussed. Puhal, there is a question: if your data normally distributed and sample size is small, what test should we go? Listen, the sample size is small. I don't know what kind of sample. Small in the sense number you have to tell, right? So suppose if you more than 70 sample you are taking it, right? And if data is normally even 36 according to the manual, you can call it as a large sample according to the manual I'm talking. And if data even 36 samples, that's with the normally distributed, because normally the experimental method they're taking the 36 sample of control group, experimental group only. But every group should be minimum 30 above is better. Every group I'm talking control group X, don't we go less than that. If they're satisfying the normality, even the sample is very, 36 above, no problem. But both the group together I'm at 36. I'm taking the control group experimental 36 plus 36. If it satisfies normality, then you can go with this parametric, right? But the thing is that if you're taking very less sample and not satisfying the normality, go with the non-parametric. So these are the condition we decide a parametric, non-parametric. So I'm just discussing once again. Hope you are getting this. The parametric and parametric decide about the four criteria that I will discuss. Now I'm just focusing. What is the equivalence of the parametric, non-parametric? This also you must be familiar. Okay. But if it is single, so listen, Pugal, if it is single group, not in single group, only single group like experimental group only, there is no control group, no problem. 36, that's a normality, go with this. I'm talking about a single group, it should having, for example, when you go with this whole sample t-test, we are taking only one group with the two tests. So at least your sample representation more than 30 is better. So if a single group means then not an issue, but kindly check it's a normality satisfying. Normally the experimental method, most of the cases that people are doing the parametric, it's satisfying the normality. Please listen this. I'm just going to highlight the equivalence of the test. So parallelly, I'm just giving the insight. What is the equivalence of the independent sample test? How we can do the man-bin test? I'm just going to do the analysis directly from the JAS software. That's the reason I'm just giving these introductions. If you like to go with the difference between the two groups, 2 minutes. Actually, the t-test nothing but, so when you like to think about t-test, the t-test talking about the comparison of the 2 means. The mean of the first group, mean of the second group, or mean of the first 2 means differences. Actually, that in the case of t-test talking about 2 mean differences only. If you like to go with the difference of the 2 means, we can go with the independent sample t-test. Even for the per sample t-test, we're talking about the 2 means only, like a pre-test and post-test means. So it is also per sample t-test. I'm talking about the data. What is the difference between independent and per sample? But I'm just giving this insight. The independent sample t-test is equal to called man-Whitney U test. So independent sample t-test is a parametric. Listen, the independent t-test is a parametric. This is a non-parametric. For the independent sample t-test equals called median test. For the per sample t-test equals called Wilcoxon signed rank. We can see the rank signed median. It's part of the is for the median. That is the reason. The rank, wherever you can find the rank, it totally is related to the non-parametric. And you can see why it is called parametric, because it's comparing the mean differences of two groups. Mean, when you take the mean, it is called mean differences, then automatically it comes to the parametric. And when you go with the one way and above, it having minimum 3 or more mean group differences, like M1, M2, M3. I have 3 groups. The 3 groups mean I want to do the differences. I want to compare the difference among the 3 groups. Then we can go with the one way and above. If you like to go with the one way and above in the parametric, the equivalence called Kreskel values test. Kreskel values is an equivalence of this. And similarly, the mean 3 groups, Pooja, don't be annotate, please, Pooja, don't be annotate. Please don't use the annotate options. Please. Okay.
Sir, how do we decide if we have to go with independent t-test or paired t-test?
I will give this clarity, madam. So I'm just going to write another things because I'm talking about the comparison. After that, I come to the when we can use the independent, when you can use the per sample test. Don't worry.
Okay.
I've just given this insight. Okay. Yes. Now I'm just talking about the comparisons. Then after that, I'm just giving this insight when you can use the different t-tests and all. Right. Next. In the case of one way and above equivalence called Kreskel values, the repeated measures are also the three means different. What is that comparison? But the 3 tests like pre-test, post-test, post-delete test in a single group, right? Then we can go with this repeated measures ANOVA and for this Redmond test. Actually, today we are discussing about these aspects. That's the reason I'm covering this. Other things we can discuss later. These are things I'm just discussing later. So now we are discussing about independent sample t-test, post sample t-test for the equivalence. There is no issue, Bhuja, no issue. It happened, not an issue. Right. The testing the difference between the more than 2 groups, Kreskel values, so that you know that one way. I'm just asking the question. You can give this. What is the equivalency of the independent sample t-test in the non-parametric? What is an alternative for the independent?
Man-made to test.
Well, it's a Fredman test for the equivalence for the parametric, for the alternative for the parametric. Fredman.
Repeated
rank
measures are no.
Repeated measures. Repeated measures. Right, fine. So at least you must be having this kind of idea. And just moving to my main task, because why I'm taking this this much of things I need to explain, because once you know the parametric, non-parametric, you can get some idea about to do further research. This reason just give the insights. Now I'm just moving to this aspect.
Memory of
Yes, I'm just going to.
Dear participants, kindly mute your audio.
Yeah, thank you. Yeah. So listen, I'm just going to open one whiteboard. Actually, there is a board called OpenBoard. It's a free tool. If you want, you can use this. It's like a whiteboard. Yeah, I'm just going to give the overview about that 3 tests, right? So do you know the number of t-tests? Do you know the number of t-tests? Any idea? Number of t-tests? How many types of t-tests?
3, sir. 3.
Very good. Three types of tests. Please kindly bear once again my poor handwriting. So bear with my poor handwriting. So the 3 t-tests, right? One is, do you know any idea what is the first one?
Sample t-test.
What is the first one? Sorry?
Independent sample t-test.
Sample
Independent sample t-test.
Yeah, so listen, one is called one sample. I'm talking about start with one sample t-test. One sample t-test.
independent
Then
sample.
second one is called, we can call it 2 sample t-test, right? Because for easy to understand, I got 1 sample t-test, 2 sample. 2 sample t-test is called independent, right? Independent sample t-test, independent sample t-test. The third one, it is called paired sample t-test. So therefore, the 3 t-tests is that. Please kindly know this. There's a 3 types of t-tests. One is one sample, other one is called independent sample, that's called 2 sample. Why in that way I mentioned is 2 sample because there's a 2 groups mean is that 2 sample group is that. That's the reason I put 2 sample. Here only 1 group is that. Therefore 1 sample. Here 1 sample represents only 1 group. 2 sample represented 2 groups means. Per sample means a single group but 2 means. Listen, the difference between these two. Azad, I'm the class. Azad, I'm the class. You can come by 8:30. Okay. 8:30 later. 8:30 later. Yeah. Sorry, sorry for this. There's a call. 1 minute. I just connected with my mobile also. Yes, I'm audible now. Yes. So we have three. One sample means we have only one sample group. That mean we have. Here we have the two means. That is called two sample mean. The two groups mean. So here one mean, only one mean, but in a group, only single group, right? It seems right. And here the two groups mean. Third means we have here one group, but two means of the two different tests. So listen, I'm just giving this insight. It's very easy to give example than easy possible. Now, one sample t-test means always this t-test, as already mentioned, that the two means comparison only. Listen. So the t-test, we needed two mean comparisons. The two means comparisons only, it's called t-test. So in the case of one sample, we have only one group. Then how we can be compared? That is the reason. The one sample t-test only meant for comparing a sample mean, yes for sample mean, with population mean. Listen, one sample t-test when we can use it mean, if you want to compare your sample mean with population mean, you have only one group, that mean is called sample mean. You have a population mean that you can find from the secondary data. From this, you can identify or find from the population mean. It's just to compare with your group sample mean, compare with the population mean from the secondary data. So if there is a comparison with sample mean and population mean, then it is called one sample, because we have only one sample mean, only one representation. That sample mean I have, I'm just comparing the sample mean with the population mean. Therefore, it is called one sample t-test. For example, I just give this insight about the business sector. Suppose I am having a car, I'm maybe a car manufacturer company I'm having. So I am creating a new, suppose the company is creating a new car. They done 100 times of trial with the new car. That new car 100 times, that's called my sample. I'm talking about the new car 100 times I'm doing this analysis. From the 100 times trial, I understood that my car is given the 21 kilometer per liter. It is an average. I'm talking about the sample average. The sample mean is 21 kilometer per liter. So it's in that my new vehicle is giving a 21 kilometer per liter with 100 times of average. This is my sample mean. The same company, it having a lot of manufacturing. From the previous history, that's called previous. I'm talking about the previous history. From this, we understood that population mean, it is 18 kilometer per liter. Okay, this is a population mean that we can find from the previous history. So it gives the 18 kilometer per liter. So 18 kilometer per liter. Now kindly check which mean is better now, whether the sample mean or the new car or the old car already exists car is better, according to the fuel. Tell me the answer.
New car.
There's a comparison. Comparisons. Which car is better now, according to the fuel consumptions?
Sample mean.
Sample mean.
Sample
New.
mean. So yeah, you understand, no? This comparison, we can use the one sample t-test. So if you like to compare with, normally the education sector, we are not using much, but the business sector, they're using it. So the sample mean, best population mean comparison, we are using a one sample t-test. Any doubt? Any doubt about one sample t-test?
No, sir.
One sample
Sir,
t-test means we have
here
only one.
population. Sir, on
Yeah.
doubt, sir. Here population means no same company, different version of cars. No? Different model
version.
of cars.
Or you can use this, for example, even when you go for buy a car. Suppose I'm going to buy a Toyota car. I'm going to compare with all other company also. Even you can go with a different company, different models. Compare with this. For example, I'm taking this new car of Toyota. So I can compare with this Hyundai company. That average, I just compare it. Which car is better? Right? That you can take it as, because car is a popular story. I'm taking this. You can compare it, right? That also better. So now we can identify which company is better. So normally, if you're taking the same company is better according to this, because that is called population name talk, right? Any doubt about the one sample? So if you like to compare sample mean with population mean, you can go with this. Now the second context, two sample t-test. That is called independent sample t-test. Independent sample t-test means we have a group 1 mean, group 2 mean. That comparison it is called. That comparison is called We have the two groups. Listen, two independent groups. For example, male mean score, female mean score. Whether the male student may be part of female, female student may be part of male. Is it possible? Why it is called independent sample t-test? Because male is an independent group. It is a separate group. Female is an independent group. So therefore, male sample never be a female sample. Female sample never be a male sample. Therefore, two independent sample. You understood why it is called independent sample t-test? We have two different groups, male group and female group. That means we are comparing. Therefore, it is called two sample. That's called independent. We are comparing the two means of the two groups. Any doubts? Two means of the
Sir,
two groups. Yeah.
here for independent sample t-test, we are testing one categorical variable having two groups with one ratio scale, ratio or
Correct.
any
Yeah,
interval scale. But in one
of
sample
course.
t-test, what about the scale criteria,
No
sir?
category. No category, madam. Only one group only. Only one group. For example, you can take as a control group experiment. Sir, for example, in this case, control group pretest score, experimental pretest score. So therefore, control group students never be a experimental. Experimental should never be a control. Therefore, two different groups, right? So
Okay.
control group pretest, experimental pretest, two different group with one scores, right? So the pretest is in according to continuous. That independent variable like control group, experimental group, categorical, right? You got it? But in this case, you can take only single group, only experimental group, for example, right? And taking only one, right? So there are correct. If it is urban, rural, of course, same. You can take it as a instead of male and female, you can go with this rural urban. That's okay, right?
In this case,
Yes. Now,
categorical variables with categorical variable also we can go with one sample t-test.
madam, no need to categorical. If you categorical, automatically two groups comes. No. If you take the male and female, automatically two groups comes. No. Then two means
Okay.
comes. You got it? Take it
Yes.
as instead of taking as a male and female, take it as a total gender as a sample.
Okay. Okay. Okay.
You got it? Don't divide male and female.
Okay.
Take it
Okay.
totally gender and do the calculation, right?
Okay, sir.
Okay,
sir.
that's called one sample, right? Take instead of dividing a male and female as a category, take it only one group as a gender as a group, right? No need to categorize our total sample. Okay. Now you can see this this one that per sample t-test. In this case, per sample t-test, I told that the two groups is the needed, but in this case, only one group, test one, and the same group, group one, test two. This comparison, it is called per sample t-test. Listen, only one group, two different types of examination or test, right? Why is called per sample? Because this test and this test is written by the same group. Therefore, it's called per sample. The samples are written the examination to the same sample written the exam two times, two interval period. Hope you are getting this. The same group written it two times. Best example in the control group. Now you can get the experimental group pre-test, experimental group post-test. This comparisons we need a per sample because both the pre-test and post written by the same group, experimental group. Therefore, it is called per sample t-test. Hope you understand the differences. Here also we are talking about the means only. Experimental pre, experimental post mean score comparisons. Therefore, it is called per sample t-test. Any doubts? Any doubts about this?
So suppose
Sir, I have
No,
one
sir.
question, sir. If in case,
Yeah,
sir,
yeah,
in the
please.
survey data, sir, and in case of survey data, can we use the per sample t-test, sir? Means in the survey data.
No.
If
Survey
suppose,
method.
sir,
No. It's not suppose. Based on the hypothesis. Normally, in the case of survey method, there is no chance to have the two interval times of test. For example, you are measuring only one variable, only one time only. You cannot be conduct the variable two times, two interval you're not conducting. And another things, you have per sample t-test, there is no possibility to do in the survey method because the survey method we have only categorical variable, and we are comparing with male and female, rural, urban, or in the case of different category, we are going to compare with our dependent variable. So no chance for the survey method compared to the per sample. But in the experimental method, based on the objectives, based on hypothesis, there will be chances independent sample t-test, per sample t-test maybe comes together based on the objectives. You got it?
Yes, sir.
Survey
yes.
method, no
Yes,
chances.
yes,
Sir,
sir. Thank
Survey
you.
method, no chance. Yeah.
Sir, when we do experimental research, at that time we compare control group and experimental group. And we used to take pre and post also. So we are involving independent or sample test also and paired sample test also.
Correct. That's the reason based on the context, based on your objective. For example, just list out the hypothesis. There is no significant difference, and you can just look on it. There is my hypothesis kindly here and tell this what kind of object is possible. Sorry, what kind of analysis possible. There is no significant difference in the mean scores of control group and experimental group in their achievements. What is the hypothesis? There is no significant difference between control group and experimental group in their achievements.
Independent sample t-test
Yes, of course. Why? There's a two groups, control group and
and
experimental group.
experimental group.
And I have only one test. So the control group experiment is a categorical variable, and I have only one test. Therefore, two groups comparisons. Control group achievement, experimental group achievement. That comparisons, how many groups is there? Two groups. This two groups comparison is called independent. Can you give the another hypothesis? Can you give this answer? There is no significant difference in the mean scores of pre-test and post-test scores in the experimental group. There is no significant difference in the mean scores of pre-test and post-test.
Paired
For example,
sample t-test.
for example, why? Because the test is two, pre-test and post-test. Pre-test and post-test, and we are comparing with only one group. What's group? Experimental. Suppose the same thing I'm doing for pre-test and post-test for control group. What calculation is better? Pre-test
Paired
post-test comparison of control group.
sample
Per
t-test.
sample.
Paired.
That's fine. Suppose I'm going to do this control group and experimental group in the case of post-test. Comparison of control group.
Independent sample.
Independent. Hope you're getting the context, right? You're getting the context? Right. So therefore, you
Sir,
understand.
I have a
Suppose I'm
query.
giving- Yeah, please.
I have the two
Please.
groups, experimental and
Uh.
control. In my experimental, there is a sample size 26, and in the control, the sample size is 29. So can we use t-test in this case? Because it is less
No,
than
that is why.
30 in
That
both
is
the
less
groups.
than 30. So in most of the cases, what is the sample, sir? What is the population? Tell me this population. What's the population?
It is
Sample.
sample is population,
What is the
sir.
sample?
Sample is 26 in experimental
No,
and 29
number
in
I'm
control.
talking. I'm not getting the sample representative. Who is the sample? Who is the sample?
Sample, these are the
Ah.
prospective teachers.
Sorry? Prospective teachers. So better to increase it because
Sample-
prospective teachers are available.
Yes.
Prospective teachers better to go with more than 30. So you cannot compare because the sample according to the statistical thumb rule is less than 30. Right? We cannot go with this parametric. Better
Less than 30.
go with more than 30 of both the groups. Right? More than 30. That will be a good practice.
So it
because
should
you may
be
get the-
more than 30.
more than 30.
It should be
minimum.
more than 30
Okay.
in one group. In one group.
Yeah, more than 30. Single group I'm talking about this.
And if
Okay,
it
will
is
be better.
class 9 students, sir, then
Sorry, ma'am.
if it is class 9 students, then what should be the
Whatever
sample size?
name, because no, these are samples are available. Why don't know why you are restricted the sample size only 29, 26. You can take even the 9th stand, there will be 5 sections. Take it one section, even the section having 50 member in a single section. Take it to one section, like you can go with a convenience sampling of 2 classrooms. Take it as a section as a control group, B section as an experimental. Why you need to be less than them? Where the sample is 9th standard, or in the case of pre-service teachers, we have a good samples number. Then why you need to limit the numbers? Because when you limit the number, the problem with this sample size, we cannot generalize it. We cannot generalize it. We have the possibility to get this more number than why you are confined with very less number. Suppose you are taking this, there is a problem, some kind of what is that? Language difficulty students we are taking. For example, out of 50 students, you can find only the learning difficulties only 5 or 6 students. Then there is a chance number of sample may be less. But you are taking as a normal student as a sample representation. Then why you need to limit the numbers? Hope you are getting my questions. Because your sample, your population is wider. Suppose you are taking this only for the problematic student in the classroom, there will be numbers of sample may be less. Then you can think about the non-parametric sampling and go with the non-parametric. But in your case, there's a chances most chances to having more number of sample. So kindly think about that as well. Hope you're getting this. Always, if your sample is accessible. Yeah.
Sir, if I'm having control group sample as 43 and then experimental group sample as 49, that is, there's a difference between the numbers. What shall we do then?
No issue, madam. Because we are comparing with this mean score only. We are not comparing with the 43 and 49. We are comparing the mean scores of 43 students, mean scores of 49 students. Therefore, we are comparing as a mean score. Mean score, if you go with 100 people and 50 people, the mean scores difference, not that much difference, right? We are comparing the mean scores only. There is no need to be. For example, I'm taking this male and female. Whether male and female numbers are same, most of the cases, it's not be correct. Okay, but at least both will be more than 30 to be better, right? Okay, so can we go with this? Okay.
Yes, sir.
Yes. Okay,
Yes, sir.
fine. So now we are getting this idea about the different t-tests, one sample t-test, two sample t-test, as well as the per sample t-test. Now there is a question from Shammuga Priya. When you use the survey method for analyzing pre-test posters knowledge of participating training, madam, when you think about pre-test posters, automatically is an experimental group, is an experimental method only. It's not a survey. I don't know, Suriya, you are asking the survey method for analyzing pre-test posters knowledge. When you give this intervention like a training program, it's an intervention. When you check with this before the training, after the training, that's called intervention. When checking this kind of what is that effect, whether before the treatment, after the treatment, then it's converted to the experimental. So kindly check your methodology, please. In this case, you can do the per sample. Suppose you want to come, that subject is talking. If your objectives that role that there is a comparison need for the pre-test and post comparisons of your group, then you can go with this pre-test posters of your group. Then you need a per sample test. There are two tests with a single group representation. So based on the context, based on the objectives, kindly check. Yes. Now can we go with the JAS now? So I request all to go with the JAS.
Yes, sir.
So go with the JAS software. So how to open a JAS? How to open a JAS? How to open a JAS? Madam, what about checking this impact of government scheme? So you're checking the impact, how you already impact, Suriya is asking. Already the impact happened, right? And how you can check the pre aspects of, I don't know how you are measuring it. Even though if you're checking this post, that's called exposed factor research. So there is an already the government scheme. You like to measure, then it's called exposed factor research. That research is called exposed factor research. Kindly check the methodology, right? So there is a difference between survey method and the exposed factor research. Yes, and just going back to the yes. Now I request all to open a JAS. And yesterday we so I request all the participants, if you have any questions for research, you can ask later, because now we need to cover the entire t-test and other things. If you have the doubts about your research, kindly text me in the chat. I mean, in my WhatsApp, I will give this answer. Now we can go with this our presentation things. I hope you are getting this right. You have a lot of doubts about your research, I know that, but now we need to go with our track. So I request all to ask the questions related to my presentation. That will be better for you. Yes, now I'm just going to the yesterday data. Yesterday we saved the data for survey method. No, one data we saved through JAS format. I request all to open. How to open it? Go to the three dots, three line. That's called hamburger. Click the open button and go to the computer. Yesterday, you know, where is that path? Where is it? The file you saved? Hope you saved in the desktop only. When you click the browse, you are finding this desktop. Under the desktop, you can find out the file. What is the file? Survey data set JAS. We already defined the names yesterday. Survey data set JAS. Click this open. Click this open. Hope you can see this your data set. Yesterday we defined male, female. There's 1,000 sample based. There is one data sets we have. You opened yesterday. We have 9 variables. Out of 9 variables, 6 is categorical and 3 is in continuous variable that we discussed. Those are open. Kindly react or respond in the chat box. How many of them open, please?
Yes, sir.
So hope you are all are open, please. I request all to text. Yes. Okay, fine. Others, please kindly respond. Put SS in the chat box. Those are open. Put SS in the chat box. Yes, now, fine, right. Now, shall we begin with OneSampleTTest? Can we begin with OneSampleTTest? Let's, where the T's, as I already mentioned this, what is this name? This menu bar, yesterday I talking about this menu. What is the name of the menus? Analysis menu. Analysis menu. All the menus are available. Descriptive, yesterday we done it. Now we need to do a t-test. Click the t-test. When you click the t-test, we have the, normally we are doing this p-value based, listen, we are doing these research based on the p-value, whether the p-value is significant or not significant. Therefore, we can need to go with the classical. The classical only, we are doing as a classical mode of research. So based on the p-value comparisons. So we are writing the report based on the significance with respect to p-value. Therefore, we need to go to classical. When you go to classical, we have 3 t-tests. What are the t-tests? Independent, paired, one sample. Hope you are getting this, the 3 sample t-test. Yes. Now, can we go with very fastly one sample, but it's not possible to do this and have data, but I'm just doing this. What is called one sample very fast? Click the one sample. When you click the one sample, you are getting this interface. Listen, as I already mentioned this, only one sample, how many group is there? There is no group, only one group representations only. You can take 1,000 sample at a time. There is no male and female. Listen, don't take male and female. Take it as a whole. Are you find the split variable? There is no split variable. Suppose I'm going to the independent, just showing this the difference between the two. One sample t-test, you are seeing the variable, right? You cannot find the split option. You cannot find the group option. But when you go to the t-test independent, you are getting this interface, dependent variable, grouping variable. You have the 2 boxes. You got it. Therefore, independent variable, dependent variable is needed. But in the case of one sample, in this case of one sample, we have only one box only. Therefore, there is no category. There is no divisions about the sample, right? Now, my thing that, so for example, just for example, I'm telling you, for example, my sample is 12 standard. I am conducting one achievement test for the 12 standard. I'm just selecting the achievement test only, put in the variable. Listen, what is the symbol? What is the symbol? What is the symbol? It is a continuous, like, yes, it is a scale. It is a scale variable. It's a continuous. Of course, a continuous, great. Instead of scale, you can use the word continuous. That will be easy to identify. Okay. The variable box, I'm checking the achievement only. Right. My achievements p-value is 316. DF. Why is the DF 999? What is the DF 999?
The degree of freedom, sir. And,
what is the formula for degrees of freedom? N minus 1. N minus 1. I have 1,000. Therefore, N minus 1 is 999. Right. So my p-value is less than 0.001. Right now, you can see this. There is a student t-test. Actually, the student means it's a t-test of one sample. You can see one sample t-test. And you can see this test value, or see the test value, or see the test value. This test value is called population mean. Listen, this test value is population mean. Before that, I want to know the descriptives. When you click the descriptives, you are finding this. Click the descriptives. The descriptive means talking about mean score and standard deviation. What is the mean value? For 1,000 people, what is the mean value?
6.0.
What is it?
048.
76.048. It is my mean score of 1,000 sample. It is my sample mean. Suppose I have a data. I got it from the some government agency that they conducted 12th examination. This, for example, in my 12th sample, I generated some achievement test. They got out of 176. But similarly, there is a government database. The result percentage showing this or the achievement of the one subject. They told the 83%. 83 mean scores. The population mean is, what is the population mean in this case? What is the population mean? My sample mean is 76.048. But I find it from secondary data that my population mean is 83. Who is better? Whether population mean or sample mean is better?
Population mean.
Population mean.
Yeah, automatically the mean difference is that, right? Just go to the text value, you can type. So I'm just to think that the test value is nothing but, what is the test value? What is the test value means in this case? Test value is nothing but population mean. Yes, you can type 83 here. When you click 83, my scores, now you can see this, my t-value is now changed. My p-value also changed, right? What is the meaning? what is the hypothesis? Anyone tell me what is hypothesis? There is no significant difference. Or you can see that there is no significant difference in the mean scores of sample and population.
And population mean.
Or you can take it as a population mean, sample means are same. This is an hypothesis I'm framing. So according to the results, what is the p-value? What is the p-value?
0.00.
What is the p-value?
0.20.
Less than
0.001.
I'm taking the 0.05 level. So listen, you know that I'm just giving this p-value less than 0.05 level. There is a condition. There's a 3 conditions. I'm just going to p-value less than, p greater than 0.05, p equal to 0.05. I'm taking the 0.05 level of significance, 95% of level of confidence. When you take this 0.05, like an alpha value, you can compare with the p-value with alpha value, right? P-value is less than 0.05 means it is significant. Listen, kindly note this. If p-value less than 0.05 is called significant. If p-value greater than 0.05 means not significant. If p-value is equal to 0.05 also significant. Therefore, 3 conditions your result may becomes if p-value less than, p-value greater than, p-value equal. If p-value less than significant, significant means, listen, significant means there is a significant. Therefore, the result is there is a significant. There is a significant means what? Both the groups are not same. Both the groups are not same. Okay. Therefore, what is the meaning? Both the groups are different. Therefore, null hypothesis H naught
Rejected.
Rejected.
if it's significant H naught
Rejected.
reject. H naught reject. If it not significant means both the groups are equal. Both the groups are equal. Therefore, null hypothesis
Accepted.
instead of using the term accepted is not a research term. Go with this failed to reject. Okay. Failed to reject. Okay. Failed to reject. So the not significant means failed to reject. What is significant? P is equal to 0.05.
Null
Once
hypothesis
again, null hypothesis reject. Null hypothesis reject. Right? Null hypothesis reject. Any doubts in this? Any doubt? Right. Suppose you want to know more about this. Go to my site. I'm just giving once again my website. I already added some files to you. Can you download this? It will be helpful for you to understand the context. So I request all to go to my Digikogi site. Go to statistical resources. Under this, go to the statistical references, the last one. Go to statistical references. When you go to the statistics references, I'm giving this link, statistical references. You are getting this last one, statistical references Excel format. There is a last one, statistical references Excel format, right? What do you need to do? Kindly click this one. When you go this, you are finding this, a Google Drive open. Click this Google Drive open. It directly goes to my Google Drive. I request all to download at least the first one. The second one, turn on, I'll tell you. Kindly download the first one. Download and open this file. Kindly download the first one, the statistical assumptions. Just download it and open the file. So don't what is that? Forget this file because this file I already compiled that interferences and assumptions and all. So what you can do after downloading, kindly open the file. How many are downloaded? Those are downloaded, kindly put this message in the chat box. Kindly put the message in the chat box. Okay, sure. Okay. The first one are able to, the first seat one, you are seeing the seat one. At the same p-value interpretation, I put it. So the p-value less than 0.05 or 0.0. Why I put 0.01? 95% or 99% is based on the things you decide. If p-value greater than, it is called not significant. Fail to reject the null. You can check only the null hypothesis only. Don't be look onto the alternative. And p-value less than significant, reject the null hypothesis. P-value is equal to significant, reject the null hypothesis. Hope you're getting this. The same thing I just writing given to you, kindly download. And go to the t-test. The t-test also I just give this. Go to the fourth sheet. Go to the fourth sheet. Go to the fourth sheet. So we have the sheet 1, sheet 2, sheet 3, sheet 4. Go to the fourth sheet, t-test. Into the t-shirts, I already made this OneSampleTTest. What is the comparisons? What is the comparison?
Sample mean
Sample mean and population means.
Right. Independent sample t-test. Group
Two
1 mean,
groups comparison.
two group mean, right? That's a group 1, group 2 mean. Again, first sample t-test, group 1, test 1 mean, group 1, test 2 mean. So hope you are getting this clarity, right?
Yes.
Kindly react if you understand this. I'm just giving this example also. And one more thing, the independent sample t-test is called between group. Anyone kindly explain why it's called between group difference? Because two groups is there. Between means two groups. Group 1, group 2, that comparison is called between. Within means what? Only one group.
Among
Within the group, two test comparisons. Therefore, we may call independent sample t-test, we may call
Between.
between. First sample t-test we can call
Within.
Within groups.
Okay, because within the group, you are comparing the two tests, right? So hope you are getting this, the clarity about this. So if you want, I can explore it later. Okay. Now I just come back to my thing. So now, according to this, kindly tell me whether it's significant or not. According to our distributions, I mean, according to our p-value, whether that value is significant or not. Tell me.
Not
What is our
significant.
p?
Not significant.
Not
No, please.
significant.
No, sir, that
Not
is not
significant.
p-value. That is coefficient variable. P-value is
No,
less
listen.
than 0.0. Yeah, yes, sir. 0.01.
Yeah, please,
sir,
I request
p-value.
all to check with this. What is the p-value? Don't look on the t-value. I'm talking about which value?
P-value is the
P-value.
0.0.
Yeah, so go with
0.001,
this
sir.
p-value. So what is the p-value?
That is
Less
My
than
p-value is
0.01.
0.1.
compared to 0.05. My p-value. Tell me what is my p-value? It's already less than 0.001,
0.05.
right? Then compared to 0.05,
Significant.
it is less than or greater than?
Less
It is less than.
Less than.
Is less than. If your p-value less than 0.05 or even 0.01,
Significant.
It is
What
significant.
it is significant. Significant means what? Null hypothesis.
There is a
reject.
notable
Failed.
change in.
Yeah. So what is the findings? There is a significant difference
So that null
in sample mean.
hypothesis can be rejected.
Between the
Rejected.
sample
What is
mean
the
and the
result?
population mean.
Yeah, there is a difference between the sample mean and the population. This is the results. There is a difference between sample mean and population mean. Suppose my population mean, and just to give this example, my population mean 77. My sample mean 76. Can we check with this now? Whether the changes happen in the results? So what you can do? Where you can change the 77? Where you can change the 77?
Test
Test
value.
Instead of test value, 83 can put 77. Now we can see this. The 77 is significant or not?
Significant.
Yes, it is
Significant,
significant.
sir.
It is also significant. Suppose mine population mean also it is compared to 76. Go with the 76 now.
It is not significant.
Go with
sir.
76.
Because p-value is more than 0.05.
It is not significant. What is the meaning? What is the meaning?
There is no
Null
difference between
hypothesis
the
is
mean
failed
score,
to reject.
population mean, and that sample
Therefore,
mean.
there is no significance. Therefore, both the samples are same. Of course, the four test means are same. You can see this. What is my sample mean? What is my sample mean? 76. What is my
76,
population mean?
76.
76. They both are same. You got it. Therefore,
Yes,
the
sir.
answer is same. Suppose now I'm just give this clue only. My sample means 76. My population, my sample is 76. My population means 70. Whether significant or not? Significant comes or not?
It will be significant. sir.
It will be significant. Just to type, you can put 70. Just check. Put the 70. So what it comes? It is significant. It is significant. Therefore, who is better? Sample mean or a population mean? In this case,
Sample
Sample
mean.
mean, sir.
if it's because you need to compare with the sample mean is population. Our sample means 76, but the population means 70. Therefore, the better in this case, sample is better than the population. This is the way we need to compare it, right? Any
Sir,
doubts
how
about
is
the
the population
one
mean?
query. Sir, where to
Pardon,
get
ma'am?
the population mean?
How
Yeah,
do
the
we know
population mean
population
from
mean?
yeah, got it. The population mean you can find it from the secondary data. From the history, you can find out this. It is not be predict from our. I'm just putting example, randomly done it, but you should collect from the secondary data. For example,
So
I am
my
conducting
P,
a 12th standard. Yes, ma'am.
so my p-value is shown as 2.032 into 10 raised to negative 108.
How it's showing? You are using the same JAS software only, no?
Yes. I don't know why.
Sir,
Anyone
she's
having
not
that
enter
issue?
the test value, sir. She may not
Okay,
enter
okay.
the
Madam,
test
test
value.
value. Suppose you are not enter the test value, keep it 0. What did happen? You can say this.
No, I have entered the test value as 70 and I've been entering whatever you have been saying, but my p-value is showing like these digits.
Ma'am, after entering the test value, give enter button so that it can refresh and it shows the
I did.
calculation.
You have
I
to
You
check
did
the
it?
p
Okay.
value of achievement, not of any other attribute. Please ensure that you have selected achievement only.
I have
Yeah.
selected achievement.
Okay. Kindly check. I don't know. Okay. It will be comes. Kindly refresh it once again. There will be, because all the people having the same. Only your case comes to me, there will be a problem. You may be select wrongly. Number. Kindly check whether you are using the same data set, achievement, study habits.
Sorry to disturb, sir. At times the
Yes,
system is
sir,
taking
but
slow,
still
so
if
it happens.
Oh, okay. Okay. Okay.
even if
So her
I'm
value,
using another data, p-value should be shown as less than or greater than, no?
Yeah, madam, I think yesterday you done some mistake. Go to the settings, go to the setting, go to the preference, go to the results, whether you click anywhere, you click this display exact. I think you maybe click this one. Kindly check your preference. Go to the preference, go to the results, and check
Okay.
your, kindly fix the 3 digit, kindly fix the 3 digits, and don't change. Suppose unknowingly maybe done some kind of customization in this. Kindly check with your end. Okay. It
Okay,
will
sir,
be
I
solved.
have a
Okay.
question.
Yeah.
Sir, even if so, it means that even if the mean differs only by 1 point, so p value will be significant, right?
Madam, it's not like this. Everything related to standard deviation also. It's not only a mean. Standard deviation also might influence in that. Okay. It's not only the mean, right? That you can see this when I go with the 77. It's not only, so you know that the formula for the t-test, what is the formula for t-test? Do you know the formula for t-test? What is the formula for t-test?
Q2 by N.
That is a, normally we are remembering it, but do you know the context of t-test? I'm just showing this, the t-test formula. The t-test formula, this is the signal by noise. The t-test formula, we are talking about the mean difference divided by standard error mean. No, actually that mean difference called signal, right? The difference between M1 and M2. Noise is very important. That's what deviation. The variance is very important. So that is the reason the formula for t-test, signal divided by noise. Noise create a lot of influence in this, right? So the difference between the group means variability of the groups is also a very big. So you can see this, the 2 diagrams, you can get this. Now you can see this, in this case, I have the 3 diagrams. All the diagrams, the means are located same places. You can see this is also mean M1, M2, M1, M2, M1, M2. All the 3 diagrams, I just make it ACM, same places, M1, M2. But you can see the variability varies high. Variability varies high. According to the 3 medium variability, high variability, low variability, means are no changes. M1 the same position, M1 same positions, all the M1s, M2 are same position, but only the variability making be issues. So the variability make it a chances in the case of t-scores. Hope you're getting, ma'am. That is the reason
Yes, sir.
that we are always mugged the formula. That is a problem. Actually, the formula, if you like tell me exactly, the formula for the t-test signal divided by noise. Noise is a very influence things in the case of t-test is happening, right? So now, can we go with OneSam, because normally OneSampleTTest we are not using much. I'm just going to the independent SAM-T-test. Are you ready now? Independent. Where you can do the independent SAM-T-test? Click this independent SAM-T-test. I request all to click the independent SAM-T-test, right? And one more thing, when you go with the independent, because most of us we are using the independent. When you go with the independent SAM-T-test, we are getting 3 tests. Are you able to find this? Student t-test, Welch test, man-Whitney test. Anyway, because the same thing, even the SPSS, we have only man-Whitney means it's like a non-parametric. As I already mentioned this. Independent SAM-T test, that parallel alternate is called non-parametric in the case of man-Whitney. But in the SPSS, we can find the man-Whitney in the same t path. When you do the t-test system, can you use the man-Whitney? Is it possible?
No, sir. No, sir.
No, but you can see it is very user-friendly tool. Even as a layman, you are not knowing what is an alternative for the independent t-test. You can find out the answer from here. But they've given the 3 tests. Any idea? When we can use the student t-test, when we can the Welch t-test, when we can the man-Whitney test. Even the SPSS, we have the student TTest as well the wealth teachers, but people not checking whether we are doing the student TTest or wealth teachers. That's called wealth TTest. Any difference? Any idea? When we can the student TTest, when we can the wealth TTest? Any
When
idea?
sir the
Population
variance
size.
rules are
Yeah.
violated, that variance rule violated, then that time we used wealth T-test.
Yeah, exactly. Tanya Sarkar, you are correct. Okay, please take the screenshot of this diagram. It is like a normality check. This is the conditions we need to go with this. Even it will be a T-test, I mean, student T-test or a wealth T-test, or in the case of man Whitney. So she already told us it's violating the normality. If it homogeneity violation happen, then you can decide what kind of things needed. That I'm focusing with the diagram. Listen, hope you are getting my screen. Are you able to visible? Right now, I'm just showing this when we can use this, the different T-tests, so different contexts. So the first one, I'm talking about normality. So the normality, as I already mentioned this, we can check the normality with a different way. Which other way we can check the normality? Normality check. One is number basis. Other one is diagram.
Skewness, kurtosis,
Visual.
Shapiro will come.
Shapiro, that is called statistic. You can check with this. Suppose all the three conditions, it is not showcasing that it is not be normal. Then what you can do? It not satisfied. If it not satisfied with normality, we can go with the non-parametric. Then when you can go with the man-Whitney test. So you got it?
Yes.
Man-Whitney test is the non-parametric. Suppose it is satisfying the normality. Normality checked. But automatic normality, what we can do? What kind of statistics we can go with this? Parametric. But the parametric, we need to check with this one more test called homogeneity of variance test. Like whether equal variance assumed, equal variance not assumed. Even the SPSS, no. Those who are doing these SPSS, how many T-scores will be there? Anyone tell me? In the table, how many T-scores in a single table? Two. So one is called equal variance assumed, equal variance not assumed. But most of people not aware of, they taking the first one. They're not knowing the context, just taking this. The first one is called student T-test. The second row, it is called wealth T-test. Hope you're getting this. The first row in the case of SPS is called student T-test. The second row T-test is called wealth T-test. I'm just saying this. The p-value, it is talking about the variance. If p-value is greater than means what? P-value greater than means what? Significant, not significant. Not significant. Not significant means what? Equal.
Equal variance.
Not significant means equal. Therefore, equal variance assumed. Right? Equal variance assumed. When the equal variance assumed, we can go with the T-test. Student T-test. We can go with the student T-test. The p-value greater than means what? Significant. Significant means what? Not equal. Therefore, what is called? Equal variance. Equal variance not assumed. If an equal variance is not assumed, you can go with the wealth T-test. Hope you are getting this three contexts.
Sir, where do we do this variance test? Once we do independent sample test only, we are getting this in SPSS. Then only we can find whether it is.
Yeah, when you do this independent sample T-test itself, there is an assumption called homogeneity comes the second table. The first is a descriptive. The second table is called T-test along with the homogeneity of variance test. Anil, kindly mute. Okay, yeah. Hope you're getting, ma'am. In this SPSS, when you do itself, automatically homogeneity comes the table. But we are not looking at it. We are not looking at it.
We are not able to hear your voice.
Sir, it is like, my doubt is now we are deciding which test we have to go, whether it is T-test or Welch test. In parametric.
Yeah,
so,
correct.
it is a stage of decision, but once we do independent sample T-test only, we are getting this variance test, like equally variant or equally.
Yeah, no. When you do this, I got it. But when you do this itself, automatically the assumption comes. Based on the assumption only, you can decide it. You got it. Why this in the SPS2 tables comes, in the same table 2 T values comes? Because they're given the two alternative. Based on the assumption, you can go with this, the first T-score or the second T-score. But we are not, the people is not looking onto it. There's a problem with this. We cannot criticize the SPS. When you click the independent t-test, automatically the tables are coming. We need to check the assumption. Based on this, we can select the t-score. You got it? There's 2 t-score. We need to select the appropriate t-score. Anil, please kindly mute now. I will tell this because there is the background, there's a TV is playing, right? Yeah. Right. Now, can we highlight here with the table now? Go back to your JAS. Okay. Go back here. Now we can see this. In this case,
Sir, if
we
are getting these 2 kinds of t-values when we do the calculations, so which t-value should we select?
I will come
That
back
is-
to the JAS after that come to the space. Listen, I just come here, right? First, you can see this in the data view. I mean, you are seeing this that is JAS view. Or you find the dependent variable. What is the dependent variable? Is a continuous. So I'm taking the student habits as a continuous variable. And my categorical variable is gender. Kindly keep it like this. Kindly keep this too. So I got the t-score. I got the t-score, right? I got the t-score, right? Now the question, sir, you started t-score, but whether I need to build this or main how to find? Kindly check here. There's an assumption check. Are you able to see the assumption checks? First, you can click the normality. When you click the normality, what is the normality showing? What is the normality showing? Whether the normality, what is the normality?
Not normal, sir.
It is
0.001.
It is actually it is not normal. It is not non-normal. Okay, it is not the normal. Then we can go to non-parametric. If you go to the non-parametric, which one you have to select? Which one you have to select?
Manually, sir. Manually.
Remove the student teaser. Now we can see this. What is the test? I'm getting the man with you test. I get the p-value. You got it? We need to shift first. Take this normal and then select this man with me. You got it? I got the man with you test. Any doubts? So according to the p-value of man with test, what is the meaning? The p-value is 0.476. Is significant or not significant?
Not significant, sir. More than
Not significant. Therefore, what does it mean? Both the groups means are same. Right? If you go to the descriptive, you can get this. When you go to the descriptive, mean scores 201, 202, more or less same. That is the reason my p-value is not significant. Hope you are getting this.
Yes, sir.
Now understand this scenario. So I just
So how did you decide the normality, sir?
Sir, based on the assumption checks, Safra will, based on statistical I'm checking. Suppose I'm going with the diagram. Previously, you can check with this this one. You can go with the descriptive plots also. When you go to the descriptive plots, I get the descriptive plots. You can go with this. There is another like rain plots. When you go to the rain plots, even somewhat is normal is there. Suppose you feel that is normal in the case of box plot also somewhat normal. So I'm talking about visual representation. If it visual represent satisfied, then it is also normal. Then go with this where student t-test or well-t-test. So I just go with the statistical way of assumption checks. Suppose you don't this one, you can go back to this mode like a diagram representation. If it's satisfying the both male and female, in the case of normality, you can go with the student t-test or well-t-test. It is everything can check these assumptions on it, right? So every test we need to check this assumption. Now I'm just going to highlight the things. Instead of study habits, I'm going to the achievement now. I'm just removing the study habits. Go to the achievement. I'm clicking this normality. Now you can see the data. Once again, what has happened? Independent sample t-test for the achievement. Once again, it is non-normal only is coming. I'm taking the intelligence. When you go the intelligence also non-normal, study habits also non-normal. Okay. So all the 3 things not satisfying the normality according to the statistical procedure. But when you go with this, the process of graphic representation, it's somewhat satisfying the normal. If you want to cross check, once I go to the descriptive statistics, you can keep it this study habits, achievement, intelligence, and check with this. Yesterday we discussing about skewness kurtosis value. So check with the skewness kurtosis. When you click the skewness kurtosis value, how to cross check? Skewness divided by standardized skewness values comes plus or minus 3. It is satisfying normality. You got it? This is the way we can cross check. First, you can check with this mode. If it's satisfying the normality, then you can decide for the independent sample t-test, whether it goes student teacher, well teachers. The second condition, I'm talking about the equal variance. Listen, suppose normality is satisfied as part of the numerical things. I'm just going to the equal variance. When you go to the equal variance, select the Levens t-test. When you go to 11s, you are getting this assumption checks. You can see this p-value. What is the p-value of the achievement? What is the p-value of achievement?
0.00.
What is the p-value of achievement?
That is significant, sir.
0.0. It is significant, not significant.
Significant, sir.
It is significant, right? Therefore, which test possible? Whether Welch-Test or any this one, student test. It is equivalence non-achievement. Go with the Welch. For achievement, you can go with the Welch-Test. What about the intelligence?
0.2.
Not significant.
Not significant.
Not. Then which one test is better? Student?
Student T-test.
T-test. Very good. What about study habits?
That is also not significant.
Not significant.
Student
Which is better?
T-test we can. Student
Student. You got it? Student T-test. So now what happened? So you cannot do separately all. So I'm just selecting the words and just selecting all together. Words. So I have two output. You can see this. Achievement student and Welch is there. Intelligence student Welch is there. Study habit student Welch. But achievement I can take it which one? Welch T-test.
Welch, sir. Welch.
For the intelligence I can take it as a student T-test. Study habits also can take student T-test. Hope you are getting this.
Yes, sir.
This is the way we need to select here the T-scores. Right? Student T-test, Welch also T-test. The name is called Welch based on the assumptions. So I am using the assumption called Leibniz T-test. Hope you are getting this. If you want to get this one, kindly kindly see my slide once again. Hope you are getting this normality checks. Any doubts? Check the normality first. If it's not normal, go with the Mann-Whitney U-test. Suppose satisfy the normality numerical basis or visual representation or in a statistic, but most of the cases status is not satisfying. Better to check with this normality with the numerical value like skewness divided by standard error skewness. If it's satisfying, go with this parametric. Under the parametric, we have a homogeneity variance test. Under the variance test, if it is not significant, equal variance assumed. If it p-value greater than, is significant, equal variance not assumed. Equal variance assumed means go with the student T-test. Equal variance not assumed means Welch T-test. This is the way we do the analysis. Right? Any doubts? Any doubts, please?
So
Any
for
doubts?
intelligence and for study habits, we'll be seeing Welch. Correct, sir?
Yeah. Intelligence and study habits is student T-test. Or because your p-value is above the 0.05 level. Yeah. Okay, Matt, for her it comes 1 minute. Her inputs comes student T-test. Madam, listen, kindly check sometimes your data, no, you maybe type wrongly. So kindly check. There is a chances instead of 5, I mean, you can type something in the data set. Otherwise, kindly reopen your data sets and check with this.
Okay, sir. Okay, sir. Thank you.
Sometime unknowingly, Shruti, sometime
Yes, sir.
unknowingly maybe type something, some numbers in the data set. You got it? Because the statistic degrees of it totally change from you and us, right?
Yes,
I'm checking with this
yes,
course.
sir.
There is it. Okay.
Okay, sir. Thank you, sir.
Okay, fine. Okay, fine. Please kindly check your data set. Unknowingly maybe type somewhere that are new numbers. Okay. So that may be affect. Yes. Hope most of the people are getting the same output, right? Same outputs.
Yes, sir.
Same output.
Yes.
Yes. Yes. Now we done it, right? So can we do the same for rural urban? How to do the rural urban? So can you do this? Go to the T-test. Where you can go with this? Independent sample T-test. Dependent variable. I can keep all the 3 variables, dependent variable. Then you can go to the locality. Now cross check. Sorry, I'm just to give this. I'm not telling the findings. I'm just to give this finding for this case, right? Listen, one more thing I need to be add. First, check the normality. The normality, it's not just non-normality. Basically, it's non-normality. But if you go with the skewness context, maybe satisfy normality. Then I can go with this parametric. Then go to the equal variance assume. go with the Levens test. Now check with this, which test I can use for the parametric. Study habits, which is better? Study habits, which is better? Whether student TTest or will TTest for study habits? Anyone?
So once again, repeat.
What is the
it.
study? For the study habits for the rural urban, my p-value is 0.57, Levens TTest. So it is called not significant. Not significant means I can go with the student TTest. Now second one
Sir,
is
your
greater than
screen is not
0.01.
changing.
So my screen is not
Screen is
visible.
not changing. Yes,
No,
sir.
it is with the previous
sir.
analysis.
Okay,
Ah,
okay,
yes,
one
sir.
minute. Okay, and stop sharing. I can share once again. Okay. So sometimes the network issues. Okay. Hope you're getting the new screens. Yeah.
Yes, sir.
Yes. Now, I'm just going to give some other insight about the JAS software. Before that, kindly give this insights. Suppose I want descriptive, where I can click the descriptive statistics. This is a descriptive. Kindly click the descriptive. And if you want a plot, if you want a diagram, which is the plot we need to select, descriptive or in here? Rain cloud. What is the advantages? You may get this plenty of images in a single, like a bar diagram, along with this box plot, along with this histogram. So everything you may get in a single, like a curve, you may get into this, like a normality curve. Suppose, what is this one? Any idea? The right side, there is a one more box, alternate type. Why I'm selecting the first one? What is the difference about the three? What is this one? What is this one? What is this two? Hypothesis. What is the hypothesis?
Represents
It is
null
called
hypothesis, no?
It is a two-type test. Which is a two-type test? Group 1 not equal to group 2, it's a two-type test. What about this group 1 greater than group 2, group 1 less than group 2? It is called?
Alternative, directional alternative.
It is called one-type test. Listen, suppose you are using a two-type, like you are taking the null hypothesis test, you can go with this two-type. If you're taking as a directional hypothesis, go with a one-type test. So this also you can select based on the hypothesis, right? In this case, I'm selecting this also. Well, right now, one more thing I'm just going to this idea. The results comes, hope you are getting the same results. So in this case, I'm taking, please kindly look onto my slide. So I'm taking this one. I'm taking this steady habits only. What is the steady habit score? What is the steady habit score? What is the steady habit score? 0.579 in the case of Levens test. Therefore, which one I have to take? Can I take a student TTest or in a Welch TTest?
Student TTest.
Student TTest.
Student TTest.
Okay, student TTest. The p-value. This is a p-value. This is a statistic value. Now, what is the p-value for t-test? 0.001 less than that. Whether it's significant, not significant?
Significant.
Significant or not significant? It is significant. Significant means what? Null
There is a
hypothesis?
significant difference in the study
Rejected,
habit.
sir.
Null hypothesis?
Rejected.
Rejected. Therefore, there is a significant difference between rural and urban students in
Sir,
the
I'm not getting same
Study
value.
Study
habits.
habits, sir. The study habits.
Madam Hanuman, there is a chances you may be typed somewhere in the data set wrongly. Okay. Sometimes unknowingly. So kindly check. Otherwise, the same value will comes, right? Now we can see this, the other one. I'm going to this. Now you are talking at this is significant, right? What is the final interpretation? You are talking, there is a significant difference in rural and urban. What is the final output results? The urban students are better than the rural students in the study habits. This is your findings. Listen, if it's significant, where you can look onto this? You have to look onto the descriptive statistics. Based on this, you write the interpretation. You got it? Now, what about achievement? Achievement significant or not significant according to the Levens test? Levens test, it is significant. Then which one we can take it? Welch teacher, student TTest? Welch. You can take the Welch teachers. Welch teachers significant, not significant?
Not
The p-value?
significant.
Not significant.
Not significant. Therefore, null hypothesis failed to reject. Therefore, there is no significant difference, right? There is no significant difference. What about intelligence? Not significant. Then we can take it as student TTest. It is significant, not significant.
Significant.
It is significant at significant 0.05 level. What about significant at 0.01 level or not?
Not
Yeah,
significant.
it is significant 0.05 level only. Listen, if it not be significant 0.01 level. So if you're taking 0.05 level, it's not significant. I'm taking 0.05 level significant. And significant means what you can do?
Check
You
with
can
the
write this.
score of intelligence.
Rural students are better than the urban students in
Urban
their
students.
intelligence. In their intelligence. Hope you're getting this. So these are the options are available. And one more thing I need to add. I'm just going to delete. There is an option called effect size. Do you know when we can use the effect size? This is an option is not available in old SPSS. Suppose we are using the software like 24, 25 software of SPSS, you cannot find the effect size. Do you know what's called effect size?
When we are
When you can do the effect size calculation.
experimental studies, we can use effect size.
Listen, those are using the experimental method, kindly do the effect size calculation. Kindly do. So normally the effect size calculation, we can do the Cogans D value. Automatically the Cogans D is coming. You can see when I select the Cogans D, we are getting this. There is an interpretations, 0.2, I'm writing the interpretations. If the scores comes 0.2 above, right, it is called small effect. 0.5 above, it is called moderate effect. And 0.8 above, it is called high effect or large effect. So in this case, what it comes? 0.006. Therefore, no, actually in this case, is a sorry, this is in Cogans value, sorry. The Cogans value is, don't be worried about this sign, right? Because of the mean, for example, the rural urban, rural is better than the urban. They're based on the number, what is the portions, like locations come the negative symbol, don't look onto these symbols, take the magnitude. Therefore, the 0.3 is here, large effect, small effect.
Small
Effect. So this one,
Moderate.
0.13.
Small effect.
Small effect.
It's a small. So within the 0.2 you can call small effect. 0.2 to 0.5 can call. Normally we can call 0.8 above high. 0.5 above is called moderate. 0.2 less, and after this called small. Suppose you are getting 0.0, it's not that much effect, like a negligible effect, like we call negligible 0.01 and all. So this is only meant for the experimental method. Don't use for the survey method, but I'm just selecting this. So for this not needed, I'm just removing this. But there is one more thing is needed. Some people are writing an interpretation based on this one also. Do you know this one? Location parameter. When you click this confidence interval 95%, we can easily to locate the answer from the, suppose you cannot know the interpretation based on the p-value. You can interpret the value, even you can interpret the results based on the lower and upper class interval itself. Giving the small example for this. Now you can see this. We have the lower value for the student TTest. I'm talking about study habits. There's lower to upper, right? This start with minus, n with also minus 12 to minus 6. Whether in between 0 case is there, the number in between 0 will come or not?
No, sir.
In between 0 comes,
No.
it is called no. Therefore, what is the meaning? It is significant. Now, in this case, you can see this. It starts from minus 2.9 plus 1.62. Is it secure? Whether in between zeros comes or not?
Yes.
Between these two limits.
0 comes in between.
If it, therefore, it's called not significant. Instead of looking onto the p-value, we can look onto this also. 0 means same. If it in between no 0 means no same, like not be same. You got it. Now you can see this. The lowest is 0.153, 0.6. The highest is 7. In between zeros comes or not? In between the number 0? No. Right? There is no 0. Therefore, it is called, what is this called?
Significant.
It is significant. It is significant. Even we can write the interpretation based on this also, right? Based on this also, we can write. This is called location parameter. In some people are using the location parameter also interpretations instead of a p-value. You can use any mode. You can use the p-value or in a class what is that, confidence interval based. So hope no doubt about this one.
One also we can use 99%, sir.
You can use the 99 also. Suppose if you want to go to 99, go to 99. Good. Thank you so much to remind me. So you can go to 99%. Now the scores might be changed. Now you can see the first one. You can see the first one. You can see the both, right? Sorry, I'm just taking this. So you can take this both the cases. Whether in between zeros comes? In between zero? No.
No.
That's
No,
what
no.
is the meaning? Significant. In between zeros comes?
Yes, sir. Yes, sir.
Yeah.
Zero
Sir.
to it will come.
Not significant. Significant but not significant. In between zeros comes?
Yes, sir.
Yes.
It will come.
Yes. See, in the previous cases, when you go 0.05 level, it is significant. But when you go to 0.01 level, it is not significant. You got it. The previous example, the same thing we
Yes,
done
sir.
it, but it comes to significant. But this case, 0.01 level is called not significant. So base, you can look onto this also. Hope you are familiar now, T-test, I mean, independent sample T-test. Got it?
Sir,
Yeah.
so instead of p-value, can we stick to lower and upper mean difference?
You can write anything, but normally traditionally the classical mode we are using with the p-value, but there is a pattern that people are writing with the lower upper value based also. But you need to write properly that interferences when you're writing this. Even you can just ask the Google ChatGPT how to write the interpretations based on the confidence interval of 95%. It gives us answer. Okay, so just check with this. All right. So hope you are able to and just give the conditions. Kindly define or kindly decide what kind of calculation you want to do this. Suppose my data set not satisfying the normality when you do the t-test, independent sample t-test. Which one I have to do this? Which one I have to do this? Man-made test. Can we do the man-made test directly from this path? Suppose I want to get this man-Whitney also. Select this man-Whitney, you can get this man-Whitney also. This is an advantage of JAS. Whether the same thing possible to SPSS? Anyone tell me?
No, sir.
I do the three
No, sir.
analysis
It is not
attested.
possible.
No.
Yeah. So therefore, which is an user-friendly tool? Which is an
JAS.
user-friendly tool? JAS.
Yes,
Right? So now you can see this, the note also there. The student t-test and well-test location parameter is based on the anyone read this? Is based on the
Mean difference.
mean difference.
Yes, sir.
When you take its mean differences, it is called parametric. You got it. But you can see this for man-Whitney, the location parameter. What is called location? It is called position. Position is part of the rank. Then what is called?
The lower and
Non-
upper.
It is called non-parametric.
Non-parametric.
It is called non-parametric. You got it? So this way we can easily, this is the things you can find it from JAS only, but other tool is not supporting, because even the layman's like me, even the people, you want to know when we get the man-made test, why is called man-made test called non-parametric, you can get some idea. The mean, as I already mentioned this, when you go with the mean differences, it is called parametric. When you go with the median differences, what it's called? Median difference base, if you like to do the calculation, it's called non-parametric. Right? So now can we move with first sample t-test? Can you move the first sample t-test?
Yes, sir.
Are you ready now? Yes. So for this data we don't have. We have only survey method. So now what I'm going to do, I request all to open a data set. Yesterday I given one data set. No, what is the data set which I given? I hope you downloaded.
Sir,
data set,
experimental data set is not opening, sir.
Through the JASPA, one thing you can do, you can convert as a CSV file. So I'm just telling this. Sometime the Excel file is not opening. So I request all to open the Excel file and just go to the that data set. Go to the experimental data. It's an Excel file, right? It is an Excel file. Now what you can do, file, go to the file, save as, click the save as, and save as a CSV file. Kindly save as a CSV file. Save as a CSV file and save. I already saved, that's the reason I ask you replace. How many of them save the CSV file format? Because sometimes it makes up a CSV file, .csv. Kindly convert to CSV. Now go to the JASP now. Go to the JAS file. Open a JAS empty, okay? And just click in this remaining things, okay? Yeah, so and just go, go into the click, open. What is the path, anyone? Path, computer, browse, go to the database, data sets, select the CSV file, click open. Click open. It's open now. It is open the experimental data. Experimental data is open or not? Please kindly respond. Those are open, kindly text me in the chat box. Is it open? Yes.
Open
Okay,
now.
fine. It's open now. Okay, sometimes the XLS file not supported, kindly come to CSV file. It will go. Now, group. Kindly see this. What is the group? 1, 2 represent what? Any idea? 1 is a control group. 2 is a Shruti Mati.
Experimental group.
Okay. Anyone kindly brief it how to convert? Madam, I am just telling this. Okay. Please, Shruti, go with your Excel file.
Yes, sir.
Experimental data. Open this and go with the file. Save as. When you go to save as, the file format is there. Select the file format is CSV. Kindly find there is a CSV file format. Select the CSV file format and save the file. Please kindly save the file as a CSV format and then save this file. Then you are getting this new file in the data set. So this is a new file. Now you can open it. Yesterday what we opened, you know this how to open this. Go to the JASP and open this one. Click here, open, computer, browse. Yesterday we discussed these things and that experimental data, CSV file select and click open. Hope all are open, right? All are open? Yes. Now we need to do some kind of changes. Yes. Now the group is a 1 for control group, 2 for experimental. How to do this? Anyone? I want to define 1 is control group, 2 is experimental. How to do this?
Double click on group.
Yes, good. Then
In
it is
label.
a nominal. It's a nominal or ordinal? It is a nominal or ordinal?
Nominal, sir.
It's a nominal, right? Right. Then label.
Here,
1 for control. Enter. 2 for
experimental.
Yes, enter. Okay, fine. Now the pre-knowledge. Actually, it is an interval. Is it interval? Pre-knowledge? Pre-test knowledge score. It is a continuous or in interval? It is a continuous basically. Kindly select a scale variable. Pre-understanding is a scale. Pre-application is a scale. Pre-total is a scale. Everything is a scale only. Everything is a scale. Kindly select up to the D post total is a scale. And gender. Gender, what is the variable? Gender?
It's a nominal, sir.
Nominal. So kindly define. So click define. 1 for male, 2 for female. 2 for female. Okay, enter. Okay. Then locality. Click locality. 1 for rural, 2 for urban. Okay. Just add it. Yes, okay. Click OK. Yes, you define it now. How many of them define? So I request all to save. How to save this? Go 3 dot. Hamburger. Save as. Browse. Save as the experimental data. JASP file. Please, I request all to save the same file in the desktop as a JASP extension file. Save it. Those who save, you can type the letter S in the chat box. Type the letter S in the chat box. Those who are saved. Okay, those who are saved. Kindly type S in the chat box. Yes, Anand. Okay, fine. Okay, fine. Okay, now can we move to the next level? Okay, so now we can see this. We have the control group, experimental group, right? Now we need to do the per sample t-test. How to do the per sample? Go to the t-test. Where the per sample t-test, right? Click the per sample t-test. Right. So now can I give this hypothesis? What is the hypothesis? There is no significant difference in that control group and experimental group with respect to the pre-test scores, pre-test knowledge, for example, pre-test knowledge. So what you can do? Whether this hypothesis may be testable through the per sample test. What is the hypothesis? There is no significant difference in the mean scores of pre-test between the control group and experimental group. Can we do this test through the per sample test? Anyone?
No, sir.
No, sir, because
No,
there are
why?
two different groups.
This is positive for independent sample test only. The IPAS for independent. What will be IPAS for this? There is no significant difference between the pre-test knowledge and post-test knowledge in the control group. You got it? In the control group. Totally, how many sample I am having? What is the total sample? What is my total sample? How to find the total sample? Click here. What is my total sample? 44, for example, right? So I'm just for the, normally if 30 is better, but for the demo purpose, I'm using this. So for me, it's a 40 as a 42 is a sorry, 44, 22 experimental, 22 is in control. Now the question for you, can we go together with the calculation? Because I'm taking the group consists of 44 member, right? But when you do the analysis, I may get the 44 results only. You can see this, I'm just doing the demo now. When I do this analysis, you can see this analysis. What is my variable? Pre-knowledge. Listen, I'm going to compare the pre-knowledge with, what is the parallel test? Pre-knowledge with?
Post-knowledge.
Post-knowledge. I'm clicking this. So kindly select pre-knowledge, post-knowledge. Right? Pre-knowledge and post-knowledge. Click the descriptives. So when you go to descriptive, what is the problem? The sample size is 44, right? Is it correct? Is it correct? What is my hypothesis? What is my hypothesis? What is my hypothesis? There is no significant difference between pre-test and post-test knowledge of control group only. But I have the total groups, control group experimental. How can I avoid this? Any idea? I need only the control group only, or I need only the experimental group. Very simple. Listen, it is called filter. This option called filter. Go back to the data view. Click the group, double click. You are getting this interface? You are getting the interface? Are you getting this interface? Yes. Now we have the filter options. You have the filter options?
Yes, sir.
You have the filter option?
Yes, sir. Yes.
Yes. Select. I need only control group only. Therefore, remove it. So only you can take which one only. The filter taking only control group. Experimental groups are blurred now. Are you able to see this? Or please don't be unedited. So I'm going to conclude.
Sir, how you
15
can
minutes.
do this? Sir, how you can do this in with the experimental group? It is hidden.
I done it, no, madam. So please kindly check once again. Please, one minute, I'm just going to remove the unedit. So go back to your, madam, please, 1 minute, I just finished this. Okay. Yeah, pre-test post-test.
One nominal variable should be there, no, sir. Because two pre-test and pre-knowledge and post-knowledge, they are scale values, continuous variable.
Yeah.
Along with that, one nominal value should be there, no, sir. Then only we can go with.
What is the need for nominal? What is the need for nominal? You're
Like
talking about male and female.
Grouping variable. Grouping.
No,
variable.
that is no. That is, madam. That's for independent variable. Independent T-test only. We needed two groups. Control group experimental, and we have one test. But here group is same. Only one group only. No need for the categorical.
Okay.
Right?
Sir.
You
Yes,
understood?
sir. Now I understood.
So
Yes,
now
sir.
we need only two test comparison only. No, you have single group with two test comparison. No need for a nominal ordinal. Don't look onto this, right?
Yes, sir. Yes,
Right now, please kindly look onto this. Now my intention to go with only control group, but I have the 44 total sample is there. How to go with this? Go back to the data set. Go to the group. You have the group, no? Double click the group. You are getting this interface. We are getting the filter option.
Yes, sir.
Click this filter. I need only control group. Click this. Click this only experimental. Only control is selected. Go back to your data view. Answer view. Now what is the sample size?
22.
What is the sample size now? 22. Is 22 only for whom? It is only for whom?
Control group.
Control group. Now I want to compare the pre-understanding, post-understanding. Click this. Pre-application, post-application. Then pre-total, post-total. So I compare all four at a stage, right? You got it? How many groups? How many groups I am having? Only one group. What is the group name? What is the group name?
Control group.
What is the group name?
Control
It's a control group. It's a control group. It's a control group, right? It is a control group. Right now, it's not satisfying normality. What you can do? Tell me. Suppose I am assuming that it's a normality. So when you do this, I found that it's non-normal. It's a free distribution. Which test may possible? Which test may be possible? What is the equivalence of the personality test? Wilcoxon, you can see this. The right side. When you click this Wilcoxon also, I can get both. You got it. This is an advantage of this software. You cannot find, JAML is a similar interface, but the SPSS cannot know the alternative. You got it. This is the way these tools are unique compared to the other tools. So these tools, even the layman's like us, we can use to understand that what kind of statistics possible for this. You got it now?
Yes.
Suppose I need only the Wilcoxon. What I have to do? I have a student TTest Wilcoxon sign test. What I have to do? Anyone? I need to remove the
Student.
I can get only Wilcoxon only. So Wilcoxon rank. So rank represent is a median, right? Like a portions. When taking the portions, it's talking about the non-parametric, right? I'm just taking this both. Okay, I'm doing the Wilcoxon. If you want to get a diagram, what you can do? Descriptive plots. Can we go with the effect size? This can we do this effect size calculation for experimental method? Yes, we need. Click the effect size. Automatic cogensity value. All the cogensity value. What is the meaning? What is the cogensity value? It's about 2.
About 2.0. It is small effect.
No. Madam, 0.2 only small. 2 above.
Okay. Yes, sir.
0.8 above. What is the meaning? 0.8.
That's a high effect.
It is a high effect. It's a large effect. It's a large effect. It is a large effect.
0.08.
Yeah, it is 0.08. 0.08. I'm talking, sir, 0.8. 0.8 above, it is called large. So in this case, 2 is a higher compared to the 0.8. Therefore, it's called, it's a large effect. What is the meaning? Anyone tell me what is the meaning of this? Effect size means?
Intervention effect, how?
Intervention effect of pre-test and post-test knowledge are very effect because after the intervention, the effect is much, right? After, suppose I want to do the experimental method for this. What you can do, anyone? I done it for first sample TTest. I'm just going with this. How to edit this? How to edit this? I want to add this control group.
Black color. Black.
Yeah. Go with the control group. Okay. Control group. Yes. Now I want to go with the experimental group also. Tell me how can I do this? The same thing only, but I want to keep the experimental. What you can do?
Duplicate.
Very good. Duplicate. And keep the duplicate. So what you can do now? Go to the data set. What you can do now?
Enable the experimental and disable the control.
Perfect. Good. Now come to this. Now we get the new output. Right? Now you can see this. The previous cogensity, you can see the previous cogensity. You are getting this answer. Sorry, automatic is come. You can see this. Yeah. You can see this. The previous one is comes to something, right? 2 point something. Right? Now we have the 4. Why? Any idea? Because the experimental group. It is an experimental group. Experimental group affects more than the control group. That's the reason this causes the cogensity value high. Now tell me the interpretations. Tell me the interpretations. What is our p-value? What is our p-value? For all the 4?
Sir. All these 4 significant, sir.
Significant for all the cases. That's what is the meaning? Your null hypothesis?
Rejected.
Null hypothesis are rejected, sir.
Reject. Therefore, what is the finding? There is a significant difference between pre-knowledge and post-knowledge in the control experimental group. It's an experimental group, sorry. There is this, because we copied this in the control group, but basically it's an experimental group. There is a significant difference in the pre-understanding and post-understanding in the experimental group. There is a significant difference in the pre-application and post-application in the control group, experimental group. There is a significant difference in the pre-total and post-total in the case of experimental group. Right? Getting into this are the mean scores. These are the mean scores. This is the n value. Right? How to check this location parameter? Click the location parameter. Can it give this explanation whether the location parameter? So location parameters satisfying this. When you go to the location parameter, all is significant. No, kindly say this. Location parameter. Where is the location parameter with 95%? Now, is significant or not significant?
Significant.
Yeah. How? Why is significant?
Because no zero comes in between.
In between there is no zero. In between zero comes, it is called not significant.
Not significant.
In between no zero, it's called significant. Therefore, all the cases no zeros comes, right? Because minus start, minus with the end. Therefore, all is called significant, right? And the effect size is also so high. The effect size is also high. This way we can write the interpretations based on the per sample t-test. Any doubt about per sample? Per sample t-test. So what is the hypothesis? Anyone tell me what is the hypothesis for this? What is the hypothesis? For this, anyone give this hypothesis for this case? What is maybe hypothesis for this? There is no significant difference between pre-knowledge
and post-knowledge in the
post-knowledge
control groups.
In the experimental group.
Control group or experimental group? Control group or
Experimental
experimental, anyone, okay? Experimental group. In this case, sorry, I'm just in this experimental group. So sorry. Experimental group, okay. Okay, so now we covered all the three independent sample t-tests, dependent sample t-test, as well as the one sample t-test. Any doubts about these three things? Independent, per sample, and one sample. Any doubts?
No, sir. No, sir.
Right. So I request all, if possible, today night, what you can do, click this options, go with this open, go with the computer, sorry, data library. We have the t-test. This is for the independent sample t-test score. This is for the independent sample t-test score. You can pair sample t-test score. Like this, we have different scores. So kindly started do analysis, right? Do the analysis with this. Got it. So we have some data set, model data set. Kindly do some analysis with this. Okay. So you may get some kind of idea how to do further about your t-test. And I'm sharing the slide also. One more thing. So now we can conclude because we already reached 8:30. Tomorrow I'm start. If possible, tomorrow I request all to join 15 minutes before. Is it okay? 6:15. We can start 6:15.
Yes, sir.
Because I need to cover ANOVA also. Tomorrow ANOVA, ANCOVA, MANOVA, these are things we need to be discussed very fast in this. And one more thing, if you need to be further about these things, once again, go to my site. In this site, if possible, you can download all. One more thing I'd like to tell. Suppose you want to know about effect size. I'm already added one of the good features in this. Go to the third, what is that? The third number. I request all to download. It's a wonderful tool. I found it today morning and I downloaded, I shared to you. This is developed by one of, this totally is in Excel. Even if you're not be good into Jamavi or Jasper and the SPSS, if you have the basic input, you can import the input from directly from the site. I mean, this is in one of the Excel calculation. Everything's available. You can just give the data, it giving this response to you. Now you can see this. This is an interface. Are you able to download the third one? The third one, 3 effect size and t-test multi-tools.
Yes, sir.
How many of them downloaded? Right. Now there's an instruction. There's a critical value, effect size samples, effect size between. So effect size single group doesn't listen. Single group means it's a one sample. Effect size between means any idea? Effect size between means what? Effect size for independent sample. Effect size within means what?
One
effect size
sample.
within means what?
Within one
paired sample.
Per some t-test. Per some t-test. So the table value, two type, they given the table value also. Suppose you want to know the table value, you can see this here. Suppose the alpha value is degrees of freedom is 99, type 99, and tails, I mean, two tail means type two tail. Your table value is 1.984. We can easily find the table value here. Is for the one tail test. Suppose my degrees of freedom 99, my one tail value. So my table value is 1.66. Are you able to see this? This is like a calculator. They made it some kind of statistical calculator. It's a very good tool. And if you go to the critical value, we can find this. For example, my t-score. Suppose you want a p-value. If you know the p-value, my p-value is this one, like 7.83. Okay. My degrees of freedom 44. Two-tail test. When you go to the two-tail test, you can see this my p-value. Are you able to see the p-value?
Yes, sir.
Suppose I'm keeping automatically the calculation comes. It's like a Excel calculator. It is developed by the man, Tody Daniel. It's a wonderful tool. We can explore it. Everything we can do manually. Even you can cross check that SPS JAMA we has put or JASP output into there and check with this cogensity value, whether the same cogensity is coming, right? These are the other cogensity HG and class delta. These are the other effect size, but normally we use the cogensity. Okay, can we wind up now? So hope this Excel file is good for you. It's like a calculator.
Yes, sir.
Yes, sir.
You can import the data, you are getting this. That's it. I shared this. A very good tool.
Thank you, sir. Thank you, sir.
Okay, so can we wind up tomorrow? If possible, 6